Hello everyone, and welcome to CRAMSURG, Clinical Research Appraisal and Methodology for Surgical Trainees, where we pick a paper fresh from the press on a hot general surgical topic. We review it for you, we present it for you, we critique its methodology for you, and provide top-of-the-field expert opinion and teaching on research appraisal and methodology. My name is Gio Perin, and together with Professor Sababala Subramanian and Maria Digby, we bring you CRAMSURG from the wonderful region of the Yorkshire and the Humber.
So, as I said, this is the first of hopefully a few lectures on statistical tests. It will be very practical. And today we're going to talk about assumptions. And hopefully I'll be able to explain a bit better what assumptions are and give you an example of one very important assumption and how to test for it. A couple of disclaimers before we go ahead. First of all, I'm not a statistician, and everything I know about statistics and running statistical tests is based on my own experience of having done things, experimented, tried, read, learned over the years, but I don't have a qualification in it. And I'm not an expert in statistical software. I've used them numerous times, and I've spoken about statistical tests before, but certainly I'm not an expert as such. So I'm sorry if there might be some hiccups every now and again, but again, everything I've learned about those stats and those software is just because of trial and error and reading and learning. So let's start with a few important things about statistical tests. Well, whenever we start working on a project and we are collecting our data, the first thing we start thinking at is, I'm going to run some tests and I'm going to get a p-value. Now, that's all very nice. And certainly this is the way I felt when I started working on my first research project back in med school. But what I didn't realize is how, well, first of all, it's not exactly easy. And secondly, you kind of need to know how to handle your data and what type of data you're dealing with. I'm not going to go into details about how we classify data and how we describe data. We've run a number of sessions. Chapters 13 to 15 particularly deal with descriptive statistics. Which one should you choose? Tables and the special tables and charts. And I'd encourage you all to have a look at them because they explain in details how to classify data and how to handle it in the first instance. Probably the most important things to remember for the purposes of this presentation is data can be divided in categorical data and a sort of measurement scale data, as Prof kind of split it when he presented it before. And today we're going to focus on quantitative data particularly. And as this chart demonstrates, when you are approaching your data, the first thing you should ask yourself before running any tests or using any descriptive statistic is, what type of data have I got in front of me? And today we are going to focus on continuous, and we are going to try and identify why it is important to know whether your continuous data is normally or not normally distributed, also known as skewed. To do this, we are going to use a piece of statistical software that I particularly like, which is open source and freely available. You can scan the QR code and have a look at it. It is very simple to use. It's basically a statistical spreadsheet, very similar to SPSS, but it is entirely free and open. And it is basically built on R. It's very well integrated with R, which is probably the most powerful and the most well-known free statistical software available. You'd argue statistical software in general, but the Jamovi interface just makes it so much easier to use. Now, without taking any more time, we said we were going to talk about assumptions. So assumptions are talked about a lot in surgery and in TV shows. Certainly, whenever we're dealing with a patient that's a bit difficult, we always say assumptions are the mother of all evil or all F-ups. if you like. And certainly, as Jack Richard would say, assumption in an investigations do kill. And ultimately, when you're running your own research project, you're effectively running an investigation. So whenever you are running a test, you're effectively making an assumption. And that assumption has to do with the data you've got,
such as its type, distribution, and so on. So ultimately, an assumption is a truth about your data that has to be fulfilled in order for the test that you're running to be valid. If you get that wrong, you might well get a result, a numerical one, such as a p-value, but that p-value might well be meaningless if the assumptions that are specifically relevant to that test are not fulfilled or true. So today we are going to focus on one of the most important assumptions in statistics, and this has to do with continuous data particularly. And as you can see in this diagram, the first split you meet when you go down the path of continuous data is normally distributed versus skewed.
The main assumptions you're making when you're running a test is that your data has a particular type of distribution, at least a continuous data. A normal distribution is, as you can see depicted in this image, a distribution where the data is kind of clustered around a middle point. That middle point can be any number, really, but as long as the data is equally spread on the right side and on the left side of that middle point, your distribution will be normal. In an absolutely normal distribution, a classic one, the vast majority of the data will lie within 2 standard deviations from the mean, as you can see in this diagram. Within 3 standard deviations, nearly 100% of the data will be contained. This is, as you can guess, very different from a skewed distribution. So how do you know if your data is normal? How do you know if your data looks like this? Well, first of all, you can look at the data. So you can just look at the numbers as they are, and you can look at the average value, the mean value, and you can look at the median value and determine whether they're vastly different. You can look at a number of different types of indicator of how the data is distributed, just numerically, and determine whether it is likely to be normal or not. You can really look at the data and just ask a piece of software to build you a histogram, and the histogram will either be symmetrical, like the one in the middle, and then you will know that your distribution is likely to be normal, or it will be skewed. It can be positively or negatively skewed, depending on where the median, the mean, and the mode end up lying. And I'm not going to go into details about this because, again, we spoke about this before. This is just sort of a little bit of a refresher. And finally, if you really, really need to demonstrate that your data is normally distributed, you can also run a test for normality. And this is what we're going to focus on in the next couple of minutes. The classically used test for normality is called Shapiro-Wilk test. It's been described many years ago. I believe it was a couple of years before I was born, actually, when it was described first. I won't tell you what year that is. And the assumption, well, this test, null's hypothesis is that the sample belongs to a normally distributed population, aka if I run the Shapiro-Wilk test on my data and the p-value is statistically significant, it means that my distribution, the distribution I'm dealing with, is not normal. That's plain and simple. Now, how do you do it? Well, as I said, we were going to have a go at this using Jamovi. So this is what we're going to do next. I'm quickly going to stop share. First of all, do you have any questions so far? I'll take that as a no. So, this is a data set of quite a few data points that I used for my dissertation. My dissertation was about papers and when people put them on Twitter, how well they are received and how many retweets they get, how many quotes they get, and likes, etc., etc. And as you can see, there's a bunch of variables here. Some of these variables are nominal, some of these variables are ordinal, and some of these variables are continuous. For example, retweet, quotes, and likes. Now, I needed to know if particularly the retweet variable was normally distributed or not, because I was going to run a few tests on that particular variable. So I used my lovely statistical software, Jamovi, to do it. So once you populate your spreadsheet, obviously depending on what project you're doing, there'll be different data. You can go on analysis and start by simply doing exploration and ask for some descriptive statistics. We said we were interested in retweets. So we just put retweets into variables. And as you can see, Jamovi will already give us a little bit of data here. It will tell us how many observations we've got in there, 775, how many empty cells we've got, mean value, median value, standard deviation, minimum and maximum. And you can ask for more. You can ask for interquartile range. You can ask for variance. You can ask for loads of things. Now, as you notice immediately, mean and median are vastly different. Vastly different. What does that tell us? Well, that tells us that probably this data is not normally distributed. And this is what I meant when I said, well, look at the data. Look at how it is. I can already tell you this is not normally distributed. But I want now to have a visual confirmation of this. Very simple to get it. You just go in this bottom section of the exploration panel, and you can click histogram. And as you can see, this is definitely not normally distributed. The vast majority of the data is here, but it's spread all the way out there. If you want, you could even use a bar plot. That tells you the same thing. Look, all the data is here at the bottom. Vast majority of the data is here at the bottom. Okay. And finally, if I really want a p-value confirmation that this data is not normally distributed, I just tap Sapir-Whorf test here. And as you can see, the p-value is less than 0.01. Demonstrating again that the data I'm analyzing is not normally distributed. Now, this has massive implications in terms of what type of statistical tests you run afterwards. So if I want to run a test on this data, I should use a non-parametric test. Parametric tests are used for normally distributed data. Non-parametric tests are used for non-normally distributed data. And so far, this is all we're going to talk about. Next time, we're going to start going into some more details about specific types of statistical tests. We spoke before about chi-square, so we're probably going to talk about student T, and then we'll move on from there. And
Thank you everyone for tuning in and listening. Until next time, keep running your life with our surgical podcast.